Have you ever wondered what's the difference between kilowatt, kilovolt ampere, and kilovolt ampere reactive? Why does your motor rating say kW, but your generator rating says kVA? In this video, we'll clearly understand electrical power and how kW, kVA, kVAR, and power factor are related. Electrical power is simply the rate at which electrical energy is converted into another useful form, such as mechanical power in a motor or light in a lamp. In AC systems, power is divided into three components. Real power, measured in kilowatts, which does useful work. Reactive power, measured in kilovolt ampere reactive, which sustains magnetic and electric fields. And apparent power, measured in kilovolt amperes, which is the total power supplied by the source. The relationship between these three powers is represented by a right-angled triangle called the power triangle. The hypotenuse represents apparent power in kVA, the base represents real power in kW, and the vertical side represents reactive power in kVAR. Power factor is the ratio of real power to apparent power. It tells us how effectively the electrical power is being converted into useful work. The cosine of the phase angle phi between voltage and current gives the power factor. A smaller angle means a higher power factor and better efficiency. For example, if the load consumes 80 kilowatts of real power with an apparent power of 100 kilovolt amperes, the power factor is 0.8 and the phase angle is 36.9 degrees. When the power factor is low, the system draws more current, causing higher losses. By adding capacitors, reactive power is reduced, power factor improves, and efficiency increases. To summarize, real power equals apparent power multiplied by power factor, reactive power equals apparent power multiplied by sine phi, and apparent power is the square root of the sum of squares of real and reactive power. So remember, kilowatts do the real work, kilovolt amperes reactive support the magnetic fields, and kilovolt amperes represent the total supply. A higher power factor means better utilization of electrical energy and lower losses in your system.